Okay, today we're going to finish up chapter 1. We're going to do the last part of chapter 1, section 6. Just going through the homework assignments. I mean, the example sheet I gave y'all. Okay, we've done examples 1, example 2. Look at this one here. Example 3. Solve the following inequality and place your answers in the remainder 2 sets. Before we begin that, we have three types of solutions. We have set notation, interval notation, and graphing. So what are the differences? How do you know if something is in set notation?
Because the U.
Just the U?
No, like it has set and then U and then another set.
No. No. How do we know if it's in set notation? Are you sure? Are you asking? Then what would interval notation be look like? That would be the brackets and parentheses. Then you just said if it's ordered pairs, it would be brackets and parentheses, which is what you said the set notation. So no, one of those is wrong. Which one? Which one? Yes. Set notations have these inequalities. Very good. Interval notation has parentheses and brackets. And graphing has open circles or closed circles. It's all on that sheet we did yesterday. Example 3. If I gave you this, first thing I'll ask you is what notation is that? That's interval. So we have to put it in the other two notations. So we have to put it into set notation and we have to graph it. Go ahead, work it. Don't wait for me to do everything. All right, should we finish? Whenever you do a conversion of notations, always go through graphing first, because it's easier to interpret what that says. So how do we do this in graph notation? No, it's a bracket. It's a closed circle. The parenthesis is an open circle. Now, where do I shade? In between, because this thing says between -3 and 9. That's where my answers are. That's where my X's are. So the set notation is, once I look at this, I know I go from -3, X is greater than or equal to -3, but X is strictly less than 9. Again, if that doesn't make sense, then look at the sheet we did yesterday. Example 4. if I give you a graph? That looks like this. Goes to infinity, that goes to negative infinity. That's graph. We have to have set notation and interval. So what the set says is these are my x's. So my x is less than or equal to 4, or it's greater than 9. The interval notation, since I'm looking for this part, it goes from negative infinity to 4. Infinities are always parentheses, and that's a solid, so it's a bracket. Unioned with this interval, 9 to infinity. Since it's open, it's a parenthesis. That's all there is to it. Example 5. We can have 3 parts. This is actually 2 different statements that are on here. This equation is greater than equal to 3 or negative 3, and this equation is strictly less than 9. So it's 2 parts we're looking at. What are we solving for? Always solve for x. So what do we do first? Subtract 2 from all 3 sides, right? Subtract 2. So we have negative 3. They're both negative, so the answer is negative. 3 plus 2 is 5. 4x. 9 minus 2 is 7. Then to get x by itself, we have to get rid of the 4. How? Divide by 4. Very good. So now we divide by 4. All terms. So we got negative 5 over 4 less than equal to x is less than 7 over 4. And there's your answer. The only thing different than this and what we've been doing is you do it to do 2 different sides now instead of just one side. All right. We haven't talked about if I had, let's say this. If I gave you that, what would you do first? That's the whole process. What would you do first? What would you do first? No. What would you do? If I add 2 to both sides, what's going to happen to this side? It'll be 4. So how do you get rid of 2? Subtract 2, yes. Always has to be opposite signs if you're moving it to the other side. 2 minus 2 cancel, so we have negative 3x is greater than 5 minus 2 is 3. 3. This is where the problem occurs. Okay, remember, oh, well, I'll show you two different ways. First way, I'm going to show you mathematically what's going on. So since this is negative, what we would do is we would add 3x to both sides. Because we can't have a negative in front of our x. So we have 0 is greater than 3 plus 3x, and then subtract 3. We have negative 3 is greater than 3x. So let's look, this is what's important. What has just happened? If I have a negative in front of the x, it's greater than 3. But now, if I get rid of the negative, what happened to the sign? It's now flipped. So whenever you change the sign of x, then you have to you flip the inequality. So in other words, when I said earlier, if you have a negative in front of in your x, when I said change the signs, change everything. Change that from -3 to +3. Change that from greater than to less than, and change that from +3 to -3.
This only applies if there's a negative.
Only applies if there's a negative in front of your x, your coefficient of x. Because you're solving for x, you have to get rid of the negative also. And I'm also trying to get you guys never to divide by a negative number. So it's the same thing we have here. X is less than -1. These are the same thing. So whenever you have a negative in front of your x, it's in front of the coefficient of x, change all the signs across the entire equation, including the inequality. Which brings us to example 6. -2 is less than equal to 3 minus 5x Okay, so I'll let you do this first. So we're solving for x. The first thing we have to get rid of was what? The 3. How do we get rid of the 3? Subtract 3 from everybody. Since they're both negative, the answer is negative. Add the numbers. 3 plus 2 is 5. Those cancel. 13 minus 3 is 10. Now, the coefficient in front of x has a negative. So we have to get rid of that negative sign. So change everything. Change all the signs of the numbers and change the directions of the inequalities. So from -5, it goes to +5. From less than equal to, it goes to greater than equal to. From -5x, it goes to +5x. From less than, it goes to greater than. And from 10 to -10. So change everything across the board. You have to change the signs in front of the numbers, the coefficients, the numbers, and then change the directions. Everything changes. Now we solve for x. Divide by 5. So we have 1 is greater than equal to x is greater than 10 divided by 5 is 2. But that's not it's the answer, but it's not correctly stated. Because we read left to right. 1 is bigger than -2. So what do we have to do to the entire equation? Flip it, right? So it's -2, x, and 1. So it's pointing to the -2. It's pointing to the x. There is your answer. So whenever you have a coefficient, a negative coefficient in front of x, when you get to the last part, don't divide by negative. Change everything. This is where it makes more sense. When I tell you all earlier, change across the board all the signs. This is where it makes sense. Because you have to change everything, the numbers and the inequalities. Everything gets changed.
So how do you know? So for the first step, so you subtract -3. How would you like figure out what number is to subtract from?
Well, you're solving for x, right? What do you have to get rid of first? Since that's added and subtracted, get rid of anything plus or minus first. Since that doesn't have an x, I have to get rid of that. Since it's a +3, I got to do the opposite. And since I subtracted 3 here, I got to subtract 3 to everybody. Then it changes. Since I had -5 in the middle, I got to change everything across the board. And then to get rid of the 5, since it's multiplied, the opposite of multiplication is division. When you solve for x, it's a process of opposites. So we always get rid of the bottom part of the order of operations is adding, subtracting. So when you solve, you do those first. Get rid of the lowest stuff. Then you go to multiplication, division, then you do all the special operations on
The
x.
number next to x, that's where you would start off with, right?
Well, nothing. This is the number next to x.
Yeah.
In that equation, wherever x is, whatever number does not have an x in that equation, get rid of that first.
But -2 also doesn't have x.
Well, yeah, but this doesn't have an x at all. You're solving for x. So this is the equation that you're concentrating on. This is the important one.
Okay.
Moving this one wouldn't do us anything. Or moving this one, since it doesn't have an x.
Yeah.
We only want the x. So we look at that. What do we do to get the x by itself?
You subtract it.
Subtract 3, then change the signs, then divide by 5. That's a good question, actually. This is the most common error people have with these kind of questions is, what do I start? What do I do? You only concentrate on the stuff usually in the middle where the x is.
Yeah.
And work your way out from there.
Yeah, that's where the lines help me draw lines in between each separate equation.
Yeah, actually, how many terms do we have in this equation?
3, 4.
4. There's 1, there's 2, there's 3, there's 4. Remember, a term is anything separated by plus, minus, or equals. So there's 2 of them in the middle and 1 on each side. The reason I asked that is for the next example. This one puts everything that we've talked about in chapter 1 on the table. So I have to ask you, what's the first thing you got to do?
Look at that middle equation. Makes sense.
Yep. And what do you see that the equations have? They have fractions. So what do I always say? Whenever you have fractions and equal signs, remember, treat these as equal signs. Whenever you have fractions and equal signs, what do? Get rid of the fractions. Yes. So first step. Find the LCD. What's the smallest number that 5, 4, and 2 all fit into?
10.
Does 4 fit into 10? 4 times what is 10? 20. Because 2 goes into 20, 4 goes into 20, and 5 goes into 20. So the LCD is 20. What do you do with the LCD? Multiply the LCD to each term. So 20 times 3 over 5. 20 times 1 over 4. Minus 20 times 3 over 2x is less than 20 times 3. And multiply it to each term. Then what? No. Whenever you multiply fractions, never multiply straight first. Always reduce. Because if you have two fractions and you're multiplying them, and you multiply them, you'll make them big, then you have to reduce. You might as well reduce when they're small first. It'll make it much easier. So next step is reduce. Can anything top and bottom cancel? Can the 5 and 20 cancel? It goes in there 4 times. The 4 and 20 cancels, it goes in there 5 times. The 2 goes into 20 10 times. So our purpose for doing that is to get rid of the fractions. So we found the LCD, multiplied each term by the LCD, reduced. Now we have no more fractions. So now we have to get rid of the parentheses. So we multiply each of the terms. 4 times 3 is 12. 5 times 1 is 5. 10 times 3 is 30. X. 20 times 3 is 60. These two equations are equal. Actually, these two equations are equal. Which one looks easier to work with? The bottom one. Once we get rid of the fractions, it's much easier for us to deal with. So now our last step is to solve. Solve for x, the way we've been doing it. So the first thing we have to get rid of is
What?
5. How?
Okay.
Very good. Subtract 5 from each of the sides. $12 minus 5 is 7. The 5's cancel, so we have negative 30x. Less than 60 minus 5 is 55. Now what do we do?
There's a negative.
There's a negative in front of the x.
You got to
Change everything. Change this sign, this direction, change that sign, change that direction, and change that sign. So 7 becomes negative 7. Less than becomes greater than. Negative 30 becomes positive 30. Less than becomes greater than. And 55 becomes negative 55. That got rid of the negative for us. Next step, divide by 30, because we're trying to get x by itself. -7 over 30 is greater than x is greater than. Can we simplify in this other one? Yeah, they both have what in common? They both have 5. So 5 goes into 55 11 times. 5 goes into 30 6 times. One more step. Because it's supposed to go from smaller to larger when you read left to right, but it's not. So we have to flip the whole thing. So put the negative 11 6 over here. It's got to still point to it. X goes in the middle. It has to point to it. And then -7 over 30. And that's that. That's the end of chapter 1. Any questions so far?